Before discussing what moisturizers are and how they work, we should first consider why they are needed. Our skin is porous, and in the same way it absorbs ingredients in skincare products, it's susceptible to losing water that circulates to it from inside the body. This can contribute to a variety of unwanted skin conditions such as dryness, itching, and irritation. When this happens, it's called transepidermal water loss, or TOOL. Circumstances such as injury, low humidity weather conditions, and applied products that dry out the skin can impact TOOL. Fortunately, preventing TOOL is as simple as using a moisturizer. To combat TOOL, people have began using different chemical products called moisturizers that aim to either restrict water from leaving the skin or replace water that has already left. There are 3 different types of moisturizers used in commercial products that each have different strategies to moisturize the skin. The different types of moisturizers include occlusives, emollients, and humectants.
Occlusives are the first type of moisturizers we are going to discuss. Occlusives completely lock in moisture by creating a hydrophobic layer over the epidermis. Chemically, occlusives are made up of large nonpolar hydrocarbon chains. This way, it prevents polar water molecules from penetrating the surface. The polar water molecules are repelled by the nonpolar layer. These compounds are mainly lipid or oil-based and form a very greasy and oily layer over the skin. Some popular occlusives are petroleum, lanolin, and cocoa butter. As stated before, occlusives form a hydrophobic layer over the skin. Thus, a great commercial example would be Vaseline. White petroleum is made up of a mixture of large hydrocarbons. These structures contain 25 or more carbons in a carbon chain. Therefore, they are very nonpolar molecules. They are perfect water-repelling agents and keep water molecules locked in the epidermis. Moisturizers containing dimethicone, or also known as polydimethylsiloxane, or PDMS, is another great example of an occlusive. Like the large hydrocarbons seen in white petroleum, these are large nonpolar molecules that form a water-repelling layer over the skin. PDMS is common in moisturizers that claim long-lasting moisture. However, many people would warn you about the silicones in moisturizers because they are known to clog pores and cause acne due to their non-penetrating and unbreathable nature. Lanolin is a common ingredient found in moisturizers. However, lanolin is actually a purified form of wool grease and even sometimes referred to as wool fat. This fatty compound acts once again as an occlusive. In fact, it is derived from the compound that makes sheep's coats waterproof. Lanolin's structure is known to closely resemble the molecular structure of the oil secreted by the human skin. Therefore, it is obvious why your skin would love an ingredient like lanolin, and it is commonly found in moisturizers. It is difficult to pinpoint the exact chemical structure of lanolin because wool fat is a mixture of many different chemical compounds. These chemical compounds include cholesterol and the esters derived from the fatty acids containing 18 to 26 carbon atoms, thus explaining their water-repelling nature.
Humectants are another type of moisturizers, and they are characterized by their ability to draw water in from the environment around the skin. Humectants often include molecules that are very hydrophilic and contain highly electronegative functional groups like hydroxyl groups, amines, and carboxylic acids that create polarity. Their affinity to form hydrogen bonds with water molecules is an important trait. There are many different types of humectants used in commercial products, but one of the most common is glycerin. As you can see, the molecule contains multiple hydroxyl groups that can form hydrogen bonds with water molecules outside the skin. Other types of humectants include butylene glycol, propylene glycol, urea, hyaluronic acid, sorbitol, and allantoin.
Another common type of moisturizer are emollients. Emollients can form a barrier to transepidermal water loss when applied heavily, similar to how occlusives work. But unlike occlusives, emollients also repair the skin. First, the outer layer of the skin is made up of dead cells called corneocytes that are held together by fatty layers of lipids. When there is less moisture in the air, the fatty layers tend to break down and open up gaps between the corneocytes, thus causing dry skin. Compounds found in emollients are similar to the compounds found in the epidermis, such as ceramides and fatty acids. This way, the emollients can fill in the gaps between the corneocytes and repair skin, while giving it a softer and more flexible feel. This lotion claims to penetrate fast, heal, and nourish dry skin. Well, let's look at the ingredients and see if it really does. Notice the ingredient called jojoba esters. Jojoba esters are obtained by hydrogenation or transesterification of jojoba oil. The oil itself is found in the crushed bean of the jojoba shrub in the Sonoran Desert of northwest Mexico and regions in Arizona and California. The reason why jojoba esters are used in moisturizers that heal skin is because of its close similarity to natural oils produced in our skin. The jojoba esters are able to fill in the gaps between corneocytes, formerly occupied by natural oils, and thus repair the skin by penetrating deep.
Our first natural example is honey. The main contributors in honey that give it its moisturizing properties is glucose and fructose. These molecules act as humectants because they're very polar and have many OH groups coming off of the ring and will attract water molecules towards it. And combined with the fact that honey has naturally low water content because when it's formed, bees will fan away the water to make it drier. Honey can even pull water from the air in humid conditions. Our next example is buttermilk. The main contributors in buttermilk that account for its properties are lactic acid, and lactic acid basically acts like a weak emollient because it has a carboxylic acid group which will hydrogen bond and attract water towards it, but it also has like a slight chain with the CH3 group, so it acts as a very weak emollient in its structure. Our last example is coconut oil, and coconut oil's main contributor is lauric acid, and lauric acid has a very long carbon chain attached to a carboxylic acid, and so that long chain will be able to go in organic layers such as like the top of your skin, while the carboxylic acid group will be able to go into the skin and hold the water there. So basically this will act like the long carbon chain will form like an upper layer which will prevent the water from leaving the skin, while the carboxylic acid will attract the water towards it, which will moisturize the skin. In commercial examples, when there's occlusives, they'll normally be mixed with emollients and humectants to kind of mitigate their texture.
So the only 3 ingredients you need to make your own moisturizer is olive oil, shea butter, and coconut oil. The main compounds in each of these are oleic acid, stearic acid, and lauric acid. Oleic acid acts as an occlusive, as it has like a grease-like texture and will form a film of organic layer over the skin which will prevent water from leaving. Oleic acid has a double bond in it which gives it its lower boiling and melting point, which is why it's liquid at room temperature. It also has a much longer chain than the other 2, which makes it have more of the organic properties compared to the other 2. Stearic acid is the shortest one of each, and it has a higher melting point and boiling point, which is why it's solid at room temperature and acts as an emollient. Its carboxylic acid group will bring water up to the surface of the skin, but the long carbon chain will prevent it from leaving. This is pretty much true also for the lauric acid, which just has a slightly longer chain and makes it better at preventing water from leaving. What you need for each is you need a half cup of shea butter, and then you need 2 tablespoons of coconut oil and olive oil. And you need to put these all together in a double boiler so they can heat up and become a liquid before freezing. After mixing all the ingredients in the double boiler, you need to set it on top of the water until everything liquefies. Stir it occasionally for best results. And after about 3 to 5 minutes of heating, it should all be a liquid, and you can go ahead and pour it in the glass jar. After it's in the glass jar, all you need to do is freeze it until it re-solidifies again. So after freezing it for about an hour, this is the final product. And we're gonna scoop some out and test it. So it's a little oily because of the ingredients, but after a little bit it'll soak into the skin. And that's our final product moisturizer.